Today, we are going to see other compounds which is not common to the with others. For example, this is oxalic acid. The compound is known as oxalic acid. This is benzene diazonium chloride. Benzene diazonium chloride. Any organic compound containing nitrogen in the middle will have this name. Okay. Next to one, this is called this is called azobenzene. This is called azobenzene. And this is called naphthalene. This is called naphthalene. And this is called lactic acid. Lactic acid, which is present in the curd. Next to one, this is called xylene. This is called xylene. This is called thionyl chloride. This is called thionyl chloride. Here, very close means this is called orthoxylene. This is called as thionyl chloride. These are some of the other compounds of organic chemistry. Okay. Today, we are going to see the very important or turning point in organic chemistry. I could say it is a turning point in organic chemistry, that is common organic reaction for 12th standard. 11th standard students do not go for this because it's very heavy. It is only meant for the 12th standard. I'll give a separate for the 11th standard. Okay. This is applicable for central board and also state board. It is not a matter of any like this. It's both common for everything. Okay, we'll start the common organic chemistry. First one, I'm going to take this one. This is called 1 degree alcohol. 1 degree alcohol means primary alcohol. What are the primary alcohols? Any compound containing CH2OH are called primary alcohol. I can give many examples or you can know many examples. For example, you can write this one. This is primary alcohol because of CH2OH. This is a compound containing 2 primary alcohol, glycol. In glycol, we are having 2 primary alcohol. When you write ethyl alcohol, it is also a primary alcohol, but you have to visualize like this. If you visualize like this, you can understand it is a primary alcohol. Then what about this alcohol? You may ask me, what about this alcohol, methyl alcohol? It is also a primary alcohol. Why? You have to view like this. When you view like this, you can understand it is also a primary alcohol. Then what about phenol? You can ask me, What about the phenol? Whether it's a primary or something? No, it is not at all alcohol. Don't consider phenol as an alcohol. It is entirely a different compound. So, you should reject this one. Okay. What about this compound? Glycerol. It has a complicated structure. Nothing. It contains 2 primary alcohol and 1 secondary alcohol. You see the compound containing both primary and secondary alcohol. Okay. Now we will go into this reaction of this. First of all, I am just taking primary alcohol for oxidation. Any primary alcohol on oxidation, this CH2OH changes into or converts into aldehyde. Should understand basically CH2OH converts into aldehyde. Then which on further oxidation, the aldehyde changes into acid. You see, primary alcohol changes into aldehyde, aldehyde changes into alcohol. Very simple, you can understand. But what mistake you will make? You see, when you go for this compound, what is the name of the formula? Benzyl alcohol. This is benzyl alcohol. Which on oxidation, what will say? By seeing this, very easy, convert this into aldehyde and later on into acid. That's all. Very easy. You know all the names. Benzaldehyde, benzoic acid, very easy. Okay. When you take this compound, if anybody asks oxidation of ethyl alcohol, you will be tempted to write in the wrong answer. How? What you will say? You will write like this. You will write like this. It is wrong because you have to check the CH2. What you are wrong you have done? You are converting the alcohol alone into aldehyde and acid. That's the wrong one. Don't, how to understand this one? Very simple. You convert this formula into like this. Now you can say the answer. It's very easy for you. How? This is wrong answer and this is the right answer. You see, this is the right answer. So, have in mind, which is very, very important, because this reaction will come in alcohol, aldehydes and also in acids. And all these, the reaction will be rotating again and again and again. Okay, next one, we are going to see subdivision of this reaction. Subdivision of the reaction. What subdivision? Primary alcohol oxidation gives aldehyde. Okay. What will happen if you reduce the aldehyde? What will happen if you reduce the aldehyde? Then what you would say? Oxidation of primary alcohol gives aldehyde. Reduction of aldehyde gives primary alcohol. Like this. That's all. Reverse. That's all. Very easy. But don't be tempted to write a wrong answer. Don't write like this. This is the wrong answer. What I'd say? You should convert the CHO into CH2OH. Don't write OH alone. That's a very common error done by the students. For example, I will tell you an example for this. When they ask for reduction of benzaldehyde, what you would write? See this formula. Don't be addicted to this one. You see this formula. That's all. This is the answer. Okay. Next one. What happens when you reduce acids? What happens when you reduce carboxylic acid? Many expected, not only you, even the scientists expected that the acid will be converted into an aldehyde, because when aldehyde is reduced to primary alcohol, they expected that acid will be converted into aldehyde, but it's not like that. Experimentally, what happens? Acid also converted into primary alcohol. It also goes back entirely into the primary alcohol. So, what is my answer? This is my answer. You see, this is my answer. So, aldehyde to primary alcohol and acid also on reduction gives primary alcohol. So, okay. Next one, primary alcohol on oxidation, you want only the aldehyde. You don't want the next step. You need only the aldehyde. You want to prevent the next further oxidation. Then what should you do? You should take mild oxidation agent, like this. Mild oxidizing agent like this. What is the name of the compound? Chromium anhydride. It is not chromium oxide. This is chromium oxide. We will see in inorganic chemistry. But this is chromium anhydride. Or you can use PCC like this. What is PCC? What is abbreviation PCC? Pyridinium chlorochromate. Pyridinium chlorochlorate. You just understand the name, but you write PCC. So, these two are used for mild oxidation. But if you want the primary alcohol into aldehyde, then aldehyde into acids, all these steps should be taken, means then you should go for strong oxidizing agent like this. Strong potassium acidified potassium permanganate or acidified potassium dichromate. You write any one. Acidified potassium permanganate or acidified potassium dichromate. Then what are the reagents used for such reduction? Converting aldehyde into an alcohol, acids into alcohol. For all this, you can use sodium borohydride. This is a reducing agent used to convert aldehyde into primary alcohol. So, again, I am just insisting you, try to understand all primary alcohols are converted into aldehyde and aldehydes are converted into acids. This is very important. Be careful, don't have any doubt, means you can clarify. If you have any doubt, means you can clarify. Okay. Now, I am going to the second stage. Second one. What second one? Primary alcohol oxidation. Primary alcohol means you should have this kind of structure in the middle of the compound, CHOH. If any compound containing CHOH means confirmly it is secondary alcohol. See to that the carbon should have one H. That is very important. Okay, coming to the point. Any secondary alcohol on oxidation, what happens? Changes into a ketone. You see, changes into a ketone. That's all. Anything you can write very easily. For example, if they give iso propyl alcohol on oxidation, you should say it's very easy, sir. Why? Any secondary alcohol changes into a ketone. That's all. When they give secondary butyl alcohol, don't learn all these reactions individually. Learn the concept. If you learn the concept, you are the authority of chemistry. If you learn all the reaction, means you are not going in the proper way. That's very important. So, when they give for secondary butyl alcohol, you should say nothing, sir. I'm least bothered about the book, whether it's questions new or old. You just understand like this. Any secondary alcohol and oxidation changes into ketone. That's all. Regarding IUPAC name, I'll tell you later on. Here I don't want to disturb with any IUPAC name and all. First you learn the reaction. Next one, if somebody asks you, how will you prepare this compound, that is 3-pentanone. If somebody asks you, how will you prepare 3-pentanone? You can create the answer. You can create the answer. How? You see, we are having the CO. You convert the CO into OH. You convert the CH into OH. First you do that one. Then you see this one. Now you can write the answer. You see, now you can write the answer and you write oxidation. That's all. You see, you first see the ketone, you convert the ketone into secondary alcohol. Why? All ketones are prepared from secondary alcohols. So, first you convert it into secondary alcohol and write the other side of the compound straightly. Now you name this compound, that's all. This is where you should learn common reaction. Okay, next one. This is ketone. What is the next one? Ketone on reduction. It is very, very, very easy. What will tell? Sir, secondary alcohol. That's all. Secondary alcohol oxidation gives ketone means ketone on reduction gives secondary alcohol. You reverse. That's all. It's very, very simple. Okay. What is reagent? And already I told you. The reagent used for sodium, for this sodium borohydride or PCC, etc. And for this also, you know, oxidizing agent. That's all. Next one. Next one, you are going to see alcohol with PCl5, then with PCl3 or SOCl2 or HCl. You see? So, this is a reaction. For all these reactions, you should convert the OH into Cl. That is the main product. Don't forget the main product. That's why I am rounding the main product. For anything, whether it is a BCl5 or PCl3 or HCl, anything. You should write the main product. Don't forget to write. Don't bother about this. You may think, sir, it is having 5 chloride. You are writing only 1. That is irrelevant. You write the Cl. Very important. If you write Cl, you will get major marks. And name that compound. These are what I am going to write byproducts. They are all byproducts. For any PCl5, you should add these two byproducts. You add these two byproducts. You do not name the formula. This is, of course, phosphorus oxychloride. Don't name the compound. You name this alone. Then for PCl3, this is a byproduct. For SOCl2, this is a byproduct. For HCl, this is a byproduct. That's all. This is the only reaction you have to balance. That's all. How to balance? So, I will tell you in inorganic. In inorganic, I will tell you a technical method to balance. Now we are talking about only organic chemistry. Okay. You see, you can watch 3 chloride. So you write 3 here. Don't write here. You should write here. When you write 3, the alkyl becomes 3. So you write 3. That's all. But this reaction alone is not applicable for phenol. This is not applicable for phenol. Why? Because it is also an acid, this is also an acid. That's all. Okay, next one, we are going to see acids. You see, we are going to see acids like this. Or COOH plus PCl5, or COOH plus PCl5, or COOH plus SOCl2. Here also, even though it contains acid group, it contains an OH group. You watch this OH group in acid. So what you will do? You have to convert the OH alone. That's all. Like this. Very easy. These reactions you should not learn in the individual lesson. These are common reactions. You learn through common. The rare reactions alone you should learn from the text. These common reactions you should learn from common reaction. Okay, the same way to balance. That's all. These are known as acid chloride. I already mentioned the names, how to name the compound. Without seeing the naming of the compounds of my lecture, don't go for this reaction. This will disturb you. This will have a doubt with you. Okay, next one. We are going to the next stage. ROH with sodium. Wait, before this, we'll see this one. RH plus Cl2. Cl2 is capable of converting only H into Cl, like this. That's all. It cannot convert OH into Cl. For example, if somebody asks you benzyl alcohol to benzyl chloride, like this, you check the question. What is the purpose of this question? The OH is converted into Cl. You see that one. Don't see the benzyl, ethyl and all. You see the functional group. If you want to convert OH into Cl means you choose PCl5. That's all. If somebody asks you, toluene to benzyl chloride, what is going on here? H is converted into Cl. When H is converted into Cl, you should write chlorine, not PCl5. These are very small technical points you should know. Okay, next to one, we are going to other area. What is action of alcohol with sodium? Whenever they give sodium, you see to that the H alone, not OH, H alone is converted into Na. That's all. And the H is eliminated as H2. If you want, you can balance. That's all. You can ask me, sir, we are having only one H. We are having two. What can we do? If you want to go for the balance. But see to that you are writing ONA. This is a sodium salt. That's all. If you want balance for 2 hydrogen, you write 2 here. Because of 2. For 2 R, you write 2 here. For 2 sodium, you write 2 here. That is secondary. First of all, is write the compound perfectly. What will happen if the same sodium are treated with acid? Like this. With acids. What will be the product? Same. In all this reaction, the H is converted into Na, like this. You see, the H alone is converted into Na. That's all. What about the other products? See, you write according to seeing this one. For sodium means H2. For sodium hydroxide means H2O. For sodium bicarbonate, it is water plus carbon dioxide. That's all. Carbon dioxide because of carbonate. Because of carbonate, we are just adding carbon dioxide. Okay, next one. After acids, we are going to see esterification. We are going to see esterification. Ester means, you know the formula, like this. This is the ester. Now I will tell you how to prepare the ester. An acids, when combined with alcohol in the presence of concentrated sulfuric acid, it gives a ester. That's all. Very, very, very simple. Don't go for double bond and all. How to learn? Sir, carboxylic acid combines with alcohol to give an ester. This is ester, that's all. But you should be very, very careful in one point. What's the point? This R should come from the acid. This is very, very, very important. And this R comes from the alcohol. If you know this one, you can answer any ester. For example, I'll tell you one thing. When somebody asks you, what is the action of ethyl alcohol with acetic acid in the presence of concentrated sulfuric acid, because they want to test you. First, what should you do? Casually understand the basic formula. What are the basic rules? Any alcohol, when combined with acid, gives an ester. So, the product will be the ester. Then what should you do? In the first R, you write the acid group. That is very important. And in the second R, you verify that you are writing the alcohol. That's all. This is very important. Write the alcohol. Then how to name the compound? I already told you how to name the compound. Whenever you go for the ester, you should tell in the reverse angle. Ethyl acetate. That's all. Sir, in my school, they are asking me like this. What? Sir, they are asking, how will you prepare ethyl benzoate? Directly they are asking to me to prepare ethyl benzoate. Very easy. How will you prepare? The first R you convert into alcohol. The second group you convert into acid. This is the technique. Whenever anybody asks you how to prepare ester means, you see that the first name should be taken as an alcohol and the second name should be taken as an acid. I will tell you how to write. Ethyl means ethyl alcohol. That's all. Benz means benzoic acid. Benz means benzoic acid. Then what will be the answer? What will be the answer? You will be getting the ester. What will you write here? The acid part. This is the acid part. What will you write here? The alcohol. That's all. So the product will be ethyl benzoate, any compound. If somebody asks you ethyl acetate, if somebody asks you ethyl acetate, you can tell from this ethyl alcohol plus acetic acid. Ethyl alcohol with acetic acid. That's all. This is how you prepare ester. This reaction is commonly called as esterification. And the ester generally will have a fruity smell. Esters preferably will have the fruity smell. Okay. There's a special reaction in ester. I'll tell you one special reaction in ester. You all know about jasmine oil. Jasmine oil means it consists of benzyl acetate. It is a main constant is benzyl acetate. It's an ester. If anybody asks you how will you prepare, jasmine oil means benzyl acetate. How will you prepare benzyl acetate? Don't mug up. You can tell it like this. Sir, it is prepared by using benzyl alcohol plus acetic acid. That's all. I'll write you like this. It is prepared by benzyl alcohol with acetic acid. That's all. Nothing to strain here. Using as usually concentrated sulfuric acid to remove the water. Okay, how to write benzyl acetate? Again I told you, you should write in the reverse side. First, you should write the acetate. You first write, then you write the benzyl. That's all. Why are you writing the benzyl like this, sir? Somebody may ask me, why are you writing like benzyl like this? I expect it to be like this. I expect it like this, but you are writing like this. Why I am writing this? Because the CH2 will not be at the end. The CH2 is should be placed in the middle with phenyl in the extreme. If you write CH2 in the last means it is incomplete. So that you should write in the middle. Okay, ester is over. Next one, you see hydrolysis of ester. Hydrolysis of ester using acid. This is very easy. You will tell us what? Acid combined with alcohol to give an ester. So this is the reverse. When you hydrolysis ester, you will give the acid and alcohol. You will get the same acid plus alcohol. But again and warn you, this R should be written as acid and this R should be written as alcohol. Somebody will ask with an alkali, sir, what should we do when they ask with alkali? And that is a new one. Okay, I will tell you. When they ask with an alkali means you cut the ester here and you just imagine like this. That's all. You will get the answer. You will get the answer. That's all. Same answer, but in the sodium form. That's all. Because you should basically learn means everything will be smooth. Okay. Next one. Decarboxylation. Next one is decarboxylation. D means, what do you mean by D in chemistry? You already learned in 11th standard. Remove, eliminate. This is D. Okay. Decarboxylation means remove the acid group. That's all. Remove the acid. First of all, you understand the concept. Don't learn any sentence from the book. You write your own account. I will tell you the answer. You take any acid or in the sodium form, anything acceptable. You treat with sodium hydroxide plus calcium oxide. This combination is called a soda lime. This combination, they'll ask you 1 mark. Soda lime. What will do? When you treat the acid or sodium salt with soda lime, means the acid group will be removed. But be careful. When I tell you the acid group is removed, don't write like this. This is wrong. Because you'll tell me, sir, you only told me remove the acid group. I removed the acid group. I written R. This is unstable. What is R? Methyl, ethyl. It is unstable. Then what should you do? You should write with an H also. That is important. Now it is stable. Methane, ethane, like this. Plus sodium carbonate. This is the main product. Don't forget the main product. Okay, I'll give some example. When somebody asks you, sodium acetate with soda lime, what will be the answer? You see CH3 with H, so the answer is CH4, that's all. When somebody asks you sodium benzoate with soda lime, you write the C6H5 with H is called as benzene, that's all. Wherever you want, you can use soda lime. But if you want somebody may ask you some tough question and all. How will they ask you? This is salicylic acid. You learn in phenol later on. This is called a salicylic acid. They'll ask you, how will you convert salicylic acid into phenol? Like this, they may ask you, very easy. You see, there's a phenol group, here also phenol group. Here is an acid group, there is no acid group. What should you do? Soda lime. Whenever write soda lime, the acid group will be eliminated. That's all. Okay. So decarboxylation is over. Next one, acid with ammonia. Acid with ammonia. What will happen? First you merge the ammonia with the acid. First you merge. It will form ammonium salt. For example, it's an ester. For example, ammonium acetate, ammonium benzoate, like this. Then heat this compound. You see, you remove the water like this O and this H2. What will be the remaining? That's all. That's all. So what is the product? Amide. So what I have done here? I have converted acid into an amide. I have converted acid into amide. That's all. Okay. Next one. This amide. Again, you want to convert into acid. If somebody asks in any conversion, so convert amide into acid, any amide, acetamide, benzamide, anything, you do hydrolysis. By hydrolysis, this will be converted into OH. So, you will be getting the acids. Okay. Next one. Acid amine. This is primary amine. Primary amine with nitrous acid. You see, this is amine with nitrous acid. In your book, in some book, they will write the nitrous acid like this. I already again and again am telling you, don't go for these types of formulas. First you learn very simple one. Nitrous acid means HNO2. That's all. What will it do? Sir, it will convert the amine into alcohol. That's all. It converts the amine into alcohol. Methylamine means methyl alcohol. Ethylamine means ethyl alcohol. But there is some abnormal case. What? But in the case of aniline, when you treat nitrous acid, first it gives benzene diazonium chloride. And then, when warm with water, then only it changes into phenol. So, in the case of aniline, you are getting an intermediate compound, but it's not an intermediate, it's a stable compound. So, you should pass through benzene diazonium chloride, then it will go for phenol. This is only for benzene aniline. So, okay. Next one, I am going to teach about nitration. You see, I am going to teach about nitration. Nitration means introducing a nitro group. First, you should have this idea. Nitration means nitro group. How I am going to introduce a nitro group? Very simple. You take any hydrocarbon. You treat with concentrated nitric acid and concentrated sulfuric acid. This mixture is called nitrating mixture. They ask in 1 mark. What you have to do? Be careful. You remove the H alone from the reactant and convert into product. That's all. Don't write NO3. Somebody will write NO3 because there is NO3 here. Somebody will write HNO2. No, it is a nitric acid. The nitric acid alone can convert H into NO2. This is a nitro compounds. Okay. Next one. Reduction of nitrobenzene using tin boron HCl. What happens when you reduce any nitro compound, whether it's an aliphatic or aromatic, don't bother using tin boron HCl or lithium aluminum hydride. These are all reducing agents. What will happen? Very simple. You convert the NO2 into NH2, that's all. Somebody may ask you, what about the O and all? It will convert into water. Don't bother about. You fight with the main product, NO2 to NH2, that's all. Okay. Next one, we are going to see dehydration. We are going to see dehydration. You all know that. Dehydration means remove water. Hydration means water. So I am writing one compound for this. Of course, they will give any other compound, but for sample, I am writing one compound for this. When treated with concentrated sulfuric acid, we have to remove the water. How will you remove the water? Like this. This OH and this H. That's all. How will you write the product? Don't by heart the product. When you want to write the product, you see the reactant. In organic chemistry, whenever you see the reactant while writing the products, you are the right students to learn organic chemistry very easily. Many students are writing the product without seeing the reactants. So they are all by hearting the organic chemistry. You see, what will happen? When you remove H from this one and OH from this one, what is the basic rules in organic chemistry? Whenever you remove any two groups from the adjacent carbon, again I am repeating, whenever you remove any two groups from the adjacent carbon, you should automatically introduce a double bond. That's all. This is a technique. You introduce a double bond. That's all. If somebody asks you for ethyl alcohol, dehydration, you can write like this also. You can write the ethyl alcohol like this also. Same sulfuric acid. What will happen? You see, remove the H from here, remove the OH from here. You should not remove both OH and H from the same carbon. Be careful. Don't remove the OH and the H from the same carbon. If you want, you can remove like this, or if you want, you can remove like this. When you remove like this, you should create a double bond here. That's all. Okay. Then what will be the product for this one? CH2, double bond CH2. That's all. Ethylene. Okay. This is dehydration. Next one, we are going for hydration. Before that, we'll see this one, dehalogenation. Dehalogenation means remove halogen. Remove the halogen alone. I'll write you the formula for this. You see, I'm writing in some example for this. Like this. I want to remove these two Cl. But you know the product. When you remove these two Cl means, what you will expect? Sir, there will be a double bond here. Okay, I am creating the double bond. But what is the main thing to understand? What do you expect from me? Sir, what is the reagent you are going to use to remove the 2-chloride from organic compound? This is a reagent, zinc. So, what will be the byproduct? Zinc chloride. That's all. See, if the 2 chlorides are present in the adjacent carbon means such compounds are called as vicinal halides. Again, I am telling you, if there is any 2 halogen adjacent, next to next, not like this, next to next, these categories are called as vicinal halides. And there is one more halides, gem halides. They'll call you gem halides. What do you mean by gem halides? This is a gem halides, like this. You can watch here. What are the gem halides? Sir, same carbon having the 2 halides are called gem halides. Different means vicinal. Same carbon means gem halides. So, okay. Next one. Next one, we are going to see hydration. You are going to see hydration. Hydration means what? Addition of water. That's all. When you say dehydration means removal of water, hydration means addition of water. Like this. You see, you take one compound, you add water. This is the condition, acid. What you will do? OH in the middle and H in the extreme. It is based on Markovnikov rule. I will tell you later about the Markovnikov rule. Okay. You might have learned about Markovnikov rule. What Markovnikov rule tells? Sir, the negative part of the hydroxy joins to the carbon which has the least number of hydrogen. The negative part of the group adds to the carbon having the least number of hydrogen. That's all. So, what will be the product? This is the product. See, while writing the product, what I have done? When you remove means there will be a double bond. When you add means the double bond will be converted into a single bond. That's all. When you remove means the bond increases. When you add again and again means the number of bond decreases. This is a very simple concept. Okay. This is hydration. Next one, we are going to talk about this type. RCONH2 with this bromine alkali. or reduction. And I already told you hydrolysis. This is already mentioned. But again, I'm just repeating, that's all. When you use bromine in alkali, this group is thrown away. That's all. Thrown away from the compound. This is you're going to learn in nitrogen lesson Hoffman degradation. This is called Hoffman degradation. Later on you're going to learn. Okay. What happens when you treat with lithium aluminum hydride reduction? In that case, the CO is reduced to CH2. You see the difference? Here CO is eliminated, here the CO is converted into CH2. But when you go for hydrolysis, this is already I told you, you'll be getting acids. You see the nature of reactions of amides. In one is removed, in one is converted, the other one is converted into hydrolysis. So, okay. This is you have seen about the amides. Next one, Grignard reagents category. Grignard reagent. When you say Grignard reagent means you should have this idea. You should have this idea. When you say Grignard reagent means you should have this idea. Methyl, or generally I am telling, alkyl magnesium halide. How will you prepare the Grignard reagent? Very, very easy. You have already learned in maybe in 11th standard. See, you take any halides, you treat with magnesium in the presence of dry ether, that's all. Or MgX, that's all. This is the reactions of Grignard reagent. Now we are going to see the properties of Grignard reagent. This is very simple. We are going to see the properties of Grignard reagent. First property regarding the Grignard reagent is treating Grignard reagent with 1 degree Grignard reagent with aldehydes ketones. Okay, I'll tell you. Treating with aldehyde and ketones. Before going to that area, I'll write a common reaction for Grignard reagent properties, which will help you like this. You see, common, like this, RCOR. This can be ketone or aldehyde. Oh, it can be an aldehyde. When you write H here, it is aldehyde. That's all. Okay. When these ketones or aldehyde, when treated with a Grignard reagent like this, methyl magnesium bromide, what should you do? Again, I am just repeating you, don't go for any books and guides. You follow any one method firmly, that's all. If you are just having a multi-learning means, you will be confused. Anybody will tell in their own style. I am telling in my own style. You follow any one strongly. That's very important. What I am just insisting you, first you should add Mg, Br in the top and methyl in the bottom, like this. Methyl in the bottom and magnesium bromide in the top. Then you again write like this hydrolysis. The product changes into alcohol, that's all. Other things are not necessary. I will also write like this. You leave all this category. This is not necessary. This is the main product. You will be getting an alcohol. First, you learn this common reaction. First, you learn this common reaction, like me. Then, if anybody asks any question, you can dominate. For example, if somebody asks you for formaldehyde, you see, this is formaldehyde. If somebody asks you for formaldehyde, you can answer by learning this common reaction. What will do? What will do? Like this. Same thing. MgBr in the top, H methyl in the bottom with H. You see, when you treat with methyl magnesium bromide, then what I will do? Hydrolysis. What will happen? That's all. See, if you combine this formula for your verification, you combine this formula, you will be getting a ethyl alcohol, that is primary alcohol. So, when you use formaldehyde with the Grignard reagent, certainly you will be getting a primary alcohol. If somebody asks you for phenyl magnesium bromide, don't be afraid. You just write phenyl instead of methyl. Now you see this compound, you watch this compound, it is nothing but benzyl alcohol, that's all. Now it is called as benzyl alcohol. So, okay, this is, we are seeing about formaldehyde. Now, we will go for next one. You see, this is for formaldehyde. So, okay, what I am going to do is, I am going to change for acetaldehyde. When I change for acetaldehyde, what you should do? You should also change this hydrogen into acetaldehyde. That's all. Here also you change for acetaldehyde. Here also you change. What is it getting? Secondary alcohol. That is isopropyl alcohol. If you have any doubt, you view this compound like this. Both are same. Isopropyl alcohol. You see, this belongs to secondary alcohol, CHOH. When you use acetaldehyde, you will get secondary alcohol. Okay. When you use acetone, you change for acetone like this. That's all. If any student have the technical mind to change according to the question, means he is a very successful student. Now you can understand, you are getting a tertiary alcohol. You are getting a tertiary alcohol. So, what is the conclusion of these three reactions? You will understand, sir, for formaldehyde, for acetaldehyde, for benzaldehyde. Sorry, not for benzaldehyde, for acetone. When you treat with Grignard reagent, We are getting primary alcohol, secondary alcohol, tertiary alcohol. You see, this is the concept. This will be very useful for conversion. Okay. Next one, carbon dioxide with Grignard reagent. You see, we are going to learn carbon dioxide with Grignard reagent. What will do? This one, carbon dioxide with methyl magnesium bromide. What I am going to do? I am going to write this formula slightly like this. That's all. Slightly like this. This is carbon dioxide. You see? This is carbon dioxide. Then I have to change here also. Like this. You see? MgBr in the top and CH3 in the bottom. Then how to change this one? That's all. That's all. You merge this formula or join this formula, you will be getting acid. You see the miracle. Grignard reagent prepared acetic acid, which is a liquid, from a mere carbon dioxide gas. From a gas, he has prepared acids. When you write phenyl, here also phenyl, here also phenyl. So the name of the compound is benzoic acid. In that case, the name will be changes into benzoic acids. Okay. Next one, I'm just going to tell you about two simple reactions of Grignard reagent. Not like this, slightly complicated. Two simple reactions like this. Methyl magnesium bromide, when treated with water, they'll ask you like this. When with water, so what will do when treated with water? So this is the answer. What will happen? This H will join here. Methane. And the remainder like this. That's all. When somebody gives ethyl means, you write ethane. That's all. You add one H. Methyl means methane, ethyl means ethane. Propyl means propane. Generally, you are preparing the corresponding alkane. That's all. If somebody may twist you any compound for this. Okay. Next one. Cyanide with Grignard reagent. When somebody asks like this means, don't have any tension. What should you do? Sir, when a cyanide with Grignard reagent, the compound will be in a ketone. The cyanide will be converted into ketone. Then you write these two products like this. That's all. As per question. If they give methyl means write methyl. If you give the ethyl means write ethyl. That's all. So, okay. Next to one. Cyanide. Regarding cyanide, they'll ask hydrolysis or they may ask you reduction, anything like this. When cyanide undergoes hydrolysis means you should learn like this. First, it converted into an amide. Later on, it is converted into an acid. First amide and then into acids. Okay, what happens when the cyanide is reduced? You see, when what happens cyanide reduced? I am writing the same CN but with hydrogen in the middle. So, what will be the product? The CN will be converted into CH2NH2. How will you cheat you in the competitive exam? How will they cheat you in the competitive exam? What happens when methyl cyanide undergoes reduction? Everybody will write methylamine because they learned that all cyanide or reduction gives amines. But that's wrong, you know that. What is the real answer? CH3, CH2NH2 because CN is converted into CH2NH2. So, okay. Next one. If they give any compound like this, methyl or ethyl or propyl, any compound with a benzene ring, if they ask what happens when these compounds undergoes oxidation using potassium permanganate, when they give methyl means they will tell you toluene. When they give ethyl means they will tell you ethyl benzene. For this you all know propyl benzene. Okay, we will come to the answer. What is the answer for all this? For all this, the answer will be the same product. This is the answer. Benzoic acids. The answer is benzoic acids. Whether it's a methyl or ethyl or propyls. Next one. Electrophilic substitution. For each aromatic compound, many will tell about electrophilic substitution. Don't learn individually. It's very simple. You learn common electrophilic substitution. Suppose when they say nitration means, when anybody says nitration means, what should do? You convert, you add these two, concentrated nitric acid, concentrated nitric sulfuric acid. First you write nitric acid and then sulfuric acid. So what will be the product? NO2. Whenever you do, anybody asks nitration means nitric acid, sulfuric acid giving NO2. Then they'll tell you sulfonation. Of course, this is rare. Even though it's rare, you should understand. Because somebody may go for competitive exam. What do you expect from me? Sir, you treat with sulfuric acid. That's all. You'll introduce this formula. What is the name of this formula? Sulfonic acid. For benzene means it is called benzene sulfonic acid. So, when you treat with sulfuric acid, SO3H. Then, when you treat with chlorine, using the catalyst. Cl will be introduced. Of course, the catalyst depends upon the compound. I cannot write firmly chlorine, FeCl3. It depends upon the compound. Okay. Then what are the other one? When you treat with methyl chloride in the presence of aluminum, unnitrous aluminum chloride, it is called what you will call alkylation. This group will be introduced. Methyl group introduced, it is called alkylation. When you introduce this group in the presence of unnitrous aluminum chloride, what is the name of this group? Acetyl chloride. So, it is called as acylation. Whenever you use acetyl chloride, you can call as acylation or acetylation. What group will be introduced? This group will be introduced. But regarding the full reaction, I will teach you when you go for the lessons. Now, I am just telling the general idea. Nitration means NO2, sulfonation means SO3H, then alkylation means Cl, etc. When you should treat with chlorine or bromine, Cl will be introduced, and for alkylation means methyl, and these two are called as what? Friedel-Crafts reaction. These are called as Friedel-Crafts reaction. I am just going to do one more thing very important here. What is the important thing? Which are ortho-para directing group? Which are groups are called as ortho-para directing group. You see, phenol, chlorobenzene, highly limited, anisole, aniline. These are ortho-para directing groups. Somebody can ask me, sir, you are writing ortho-para directing group means like this. What is the base for this? What are you trying to say with this? Nothing. I am just telling you now. You see, if somebody asks what is the action of anisole, you can use toluene also. Here, when somebody asks you, what is the action of anisole with concentrated nitric acid, concentrated sulfuric acid? You don't go for anisole lesson and all. You may not need all this one. But by seeing this, you can answer. Anisole means ortho-para. So what you will do? You write 2 anisole like this. You write 2 anisole like this, and 1 for orthonitration, 1 for paranitration. That's all. And the anisole will not allow the meta position for nitration. It is only avail ortho and para. Then what will you expect from me again? Sir, which are belonging to meta directing group. You see, meta is the individual, ortho-para are same side. Which are meta directing group? That's all I'll tell you. Benzaldehyde, benzoic acid, acetophenone, nitrobenzene, You see, these are meta-directing group. If somebody asks you, what is the action of benzoic acid with bromine? Somebody asks like this. You are not learned, but you can try. You will get the right answer. How? Sir, benzoic acid belongs to the meta-directing group. So, this is the answer. This is the answer. You write to the meta position. But see to that, here you should write BR2. Don't be very casual. Here you should write BR. Don't write BR2 here. Of course, plus HBr. If you want, you can write HBr. That is immaterial. What I am trying to say is, meta is very important for benzoic acid. Of course, this is the catalyst. For meta position, this is the catalyst. Okay. If somebody asks you, what is the action of benzaldehyde with bromine? Same answer. Same answer. Meta-bromo benzaldehyde. So, you just category all this one, which belongs to orthopara, which belongs to meta, then it will be very easy. These are not strained to learn. Don't learn individually according to the books. This is the common. So, learning the organic chemistry, try to understand. You concise. First of all, you should simplify. That is very, very important. Okay. I am just going to tell the last concept regarding the common reaction. This is the last concept. What is the last concept? Iodoform test. Iodoform test. What do you mean by iodoform test? First of all, I'll tell you. You take any compound. Any compound. I'll tell you all the compound later on. Generally, you take any compound. If it answers iodoform test means, you should understand this one. What? When that compound is treated with iodine and alkali, it gives iodoform. You see, it gives iodoform. It is yellow precipitate. Don't write like this. This is methyl iodide. This is methyl iodide. This is iodoform, like chloroform. Okay. This test you can use mainly for distinguish. Okay. I'll tell you which of the compounds are answerable for iodoform test. First of all, I'll tell you the technical point. You see, alcohol like this. Alcohol starting like this. CH3, CHOH. This will be some other one. Okay. Anything. Or aldehydes or ketones starting like this. These compounds are preferably, they are ready to answer iodoform test. Now, I am writing the compounds. Maybe I may miss one or two, but majority I will write the compounds. For example, you can expect me, sir, what are the alcohols that will answer iodoform test? Ethyl alcohol. You see, CH2CHOH. Then, isopropyl alcohol. Isopropyl alcohol. These will answer the iodoform test. Then, secondary butyl alcohol. If you write the structure, you can feel this formula. You can see this formula will come under this. Next one, lactic acid. This also will answer Adapom test. But it's not in your book, so we'll reject. Then what are the ketones or aldehydes? See, this acetaldehyde, because it is looking like this. Because of this format, it is answering Adapom test. Then acetone. You see? Then butanone. Then 2-pentanone. Not 3-pentanone. 3 means it will come here, it will not answer. 2 means here, 2-pentanone. Next one, acetophenone. You see, in all these compounds, they are having CH3CO. But again, I am telling you, maybe I may miss 1 or 2. But this is the technique how you should go for compounds answering the Adapom test. Then you can ask me, sir, what is the uses of learning the Adapom test? First, before telling that one, I will write one common reaction for Adapom test. Because I am just telling the vague one, I will tell with an example. See, you all know the acetone answers Adapom test. But you want to know the complete reaction. I will tell you. First, it reacts with iodine to form triiodoacetone like this. Triiodoacetone. All the 3H will be converted into 3I. Then you are treating with an alkali, because I already told you iodine alkali. This alkali, what will do? It will break the compound like this. You see, it breaks the compound like this, so that you will get the Adapom plus CH3COONA. See, this is how the Adapom reaction takes place. But what is the purpose of learning Adapom test, the compound? They may ask you in public like this, how will you distinguish ethanol, phenol, something like this. Then what you will tell? Sir, it answers Adapom test. It doesn't answer Adapom test. In some schools, they may ask you some tough question. How will they ask? Pent 2-one, pent 3-one. Distinguish these two compounds. Nothing. Pent 2-2-O means it contains like this. So, start like this. So, what will tell? Sir, it answers Adapom test. It doesn't answer Adapom test. So, these are some technique you should follow to answer the Adapom.